Okay, for the last 2 weeks, we have been working on chapter number 12, and there is actually one topic of chapter number 12 which is still not covered, and it is included in the in the material for chapter number 13. But this is the first topic which is actually of chapter number 12, and that is about the dependent motion. So inshallah, we are going to cover that topic today, and then we are going to start chapter number 13 and cover a little material of chapter number 13 as well. So most probably by next week, inshallah, chapter number 13 will be finished. I saw some of the students send me the email about the homework, but once again, I would like to make a request that you don't need to submit the homework through email. Do the homework, do your handwritten work, and keep it with you. On the day of the midterm exam or the major exam when you're going to come to the university, I will collect it from you by hand. And then after that, I'm going to grade your homeworks. So this is better because I'm teaching a lot of students, and if I just receive the homeworks by the email or so really it becomes a big mess to figure out who has submitted what and what is left. So it's better to take it by hand from you. We place deadlines over the schedule for the homeworks, but those deadlines can be ignored. But by the day when you come for the exam, you should have all the handwritten homeworks with you. Okay, chapter number 12. We have covered most part of chapter number 12. Now let's, just one part is left. Now let's cover that, which is actually included in chapter number 13 slide, but this is part of chapter number 12. And that's about the dependent motion. Sometimes we have motion like that. For example, you can see here, we have a pulley and a rope is connecting block A and block B together. Now, when you have a rope which is connecting block A and block B together, so the motion of the two blocks are interconnected because of the rope. So if you move block A, automatically block B will move as well. If you move block B, automatically block A will move as well. So such kind of motion is known as dependent motion, where one body's motion is dependent over the motion of another body. Okay, so that kind of motion is known as dependent motion. There is a specific way of actually dealing with that kind of motion. There is a specific way of treating this motion. Now what is needed here? The need is that we need to be able to create a relationship between the motion of body A and body B. Whenever you have bodies which are interconnected with each other, whenever you have bodies which are interconnected with each other, so their motions are interconnected, but we should have an equation which can relate the motion of one body with the other body. So if I know the motion of body A, I should be able to find out the motion of body B. There should be one equation that should connect the motion of body A with the motion of body B. Similarly, if I know the motion of body B, I should be able to find out the motion of body A, because the two are interconnected. So this is the main objective of this topic, to find out the equation for the motion of bodies which are interconnected, which are dependent over each other. So first of all, do you understand the topic or not? Okay. So while giving the lecture, it's better to always have a response or a feedback from the students. So during the lecture, whenever I ask you, is it clear? So I would request you to just respond me, either write on chat or you can respond me physically, so that I may feel that, okay, I can move ahead. Similarly, if anybody has any problem, you are most welcome to stop me and ask me for repetition. Maybe I can repeat and answer you. Okay, dependent motion. So regarding the dependent motion, there is some law. There are some laws which we have to keep it in our mind. I have written those laws here, and if you just follow them correctly, inshallah, everything will be fine. Okay. Point number one: specify fixed references. You need to specify a reference point for the motion. Okay. Now remember, the reference must be fixed, so it should not be movable. So this is point one. For example, if you look here, this pulley could be the reference. This pulley could be the fixed reference. Pulley is fixed. Pulley is not moving. Pulley is not going away from its location. It's fixed. So this pulley can be referred to as a fixed reference. Suppose if the pulley was able to move from one place to another, then we cannot put the pulley as the reference. So reference should be fixed. This is point number one. I hope it is clear. Okay. Next point. Draw the datum lines. Datum lines should be perpendicular to the motion of particles. Now you see here, we have here particle A and particle B, and their motion are interdependent. Okay, so let's say we selected the pulley as a fixed reference. Now we need to draw the datum line from this fixed reference. The datum line for particle A should be drawn such that the motion of particle A is perpendicular to the datum line. Similarly, we will have to draw another datum line, and that will be for the particle B, such that the motion of particle B is perpendicular to this datum line. So that is the second point. So first point was, first to specify the fixed reference. It could be one fixed reference, it could be more than one fixed reference. Okay, but whatever the reference we select, it must be a fixed one. It should not be a movable one. Second point, draw the datum lines. So here, if I show here, this is a datum line. This is a datum line for this particle because the motion is perpendicular to it. Then we have another datum line, this, okay, and this is for particle B because motion is perpendicular to this datum. So that's the second point. I hope it is clear. Okay, point number one done, point number two done. Let's go to third point. Specify positive and negative for the motion. Now, you have to specify the positive and negative for the motion. Remember, motion of particle away from datum line is positive, and motion of particle towards datum line is negative. So let's have a look here. If, for example, when okay, so if, for example, when A is moving in this direction, so do you think A is going towards the datum or away from the datum? So if it is going in this direction, then A is going away from the datum. So the motion of A will be considered positive. If A is moving, so that will be considered positive. If A is moving in this direction, then it is moving towards the datum. Then we will consider this motion negative. Similarly, if B is moving away from the datum, then this motion would be considered as positive. If B is moving towards the datum, then this motion would be considered as negative. So the first point was specify a fixed reference. Second point was draw the datum lines. Datum lines should be perpendicular to the motion of the particle. Third point is that Specify positive and negatives. Remember, whenever an object is moving towards the datum, that's the negative. Whenever an object is moving away from the datum, that is considered positive. So point number 1, 2, and 3. Are these points clear or not? Okay. Okay, so point number 1, 2, and 3 are clear. Let's move towards the point number 4. Point number 4, identify the number of ropes with variable motion. So look here, in this problem, how many ropes do you see? Just one rope. There is only one rope here. And there is variable because A and B can move, and when A and B can move from the fixed reference, SA is one variable, SB is another variable, the variables can change. Okay, so we have variables here, and we have this one rope. So this one rope is a rope with variables. So how many ropes we have here? One rope. So that's the fourth point. Identify the number of ropes. But the number of ropes should be the ones which have the variables. Okay, so there is one rope, and and this one rope has variables. So this was point number 4. Then write equation for each rope with variable motion. We need to write an equation for each rope. Okay, so let's talk about this rope. Let's talk about this rope. If I want to write the equation of this rope, so writing the equation of this rope would be like this. So the rope is starting from A. So we have SA is one length. Then add to it the length passing through the pulley. Let's call this LCD. Then add to it another length of the rope SB. This will be the total length LT. So I made an equation for this rope. Do you understand the equation or not? SA plus LCD plus SB is equals to total length LT. So I made an equation for this rope. There was one rope here, and I made an equation for this one rope. Okay, so it's simple. Now, once you have made the equation of the rope, now what we need to do is we need to differentiate it with respect to time. Once you differentiate it with respect to time, okay, look, SA is a variable. SA can change. SA can it can change. It can decrease. It can increase. Okay, so when you differentiate SA with respect to time, it will become VA. Okay, what about LCD? With the motion of A and B, do you think that this length of the rope will change? No, it will not, because it is on a fixed pulley, and the pulley is not deformable. So the shape of the pulley is same. So this length of the rope would remain the same. It's not going to change. Even with the motion of A and B, this length of the rope will not change. So LCD is a constant. When LCD is a constant, when you differentiate a constant with respect to time, what happens? It goes to 0. Then we have SB. SB is a variable. When you differentiate it with respect to time, it becomes VB. Equals to LT. LT is the total length of the rope. Do you think the total length will change? Total length will not change. So body A, particle A can move up, can move down, particle B can move up, can move down, but the total length of the rope will remain same. So it becomes a constant. So when you differentiate a constant with respect to time, what happens? It goes to 0. So when it goes to 0, So this becomes our equation for the rope. So now we have related the velocity of particle A and the velocity of particle B. VA plus VB equals to 0. That means VA is equals to negative VB. So this is the relationship between the velocities of A and B. Similarly, if we want to have a relationship between the accelerations of A and B, we can differentiate it once again. Once you differentiate it once again, it will become what? Acceleration AA plus acceleration AB is equals to 0. Okay, so we have developed the equation. Okay, let me see. Okay. So write equation for each rope with variable motion, differentiate to get velocity equation, and again differentiate to get acceleration equation. I have shown you all 6 points right now here. First of all, before moving forward, I need to know, is there any point which you do not understand? Is there anyone who thinks that one of the point you do not understand? So let me know. First point is specify fixed reference. Reference should not be movable. Then draw the datum lines. Datum line should be perpendicular to the motion of particle. Then specify positives and negative to motion. Whenever a particle is moving away from the datum line, consider it positive. When it is moving towards the datum line, consider it as negative. Then identify the number of ropes. You can have one rope, you can have more than one rope. Identify the number of ropes with variable motion. Then write equation for each rope with variable motion. Then differentiate to get velocity equation, then again differentiate to get acceleration equation. So I have written 6 points here and explained to you all 6 points. Do you understand? Is there anything among the 6 points that any one of you do not understand? Please feel free to ask. Is it clear? Good. Okay. Okay, there's the same thing written here. So VB equals to negative VA. All right, let's have a look here. Let's have a look here. Me, okay, like this, like this. Okay, so again, now we need to see here, we see here there are two particles, particle A, particle B. If I move particle A, this rope is going to make this pulley to move up and the particle B will move up. Okay, so the motion of the particles, if A moves like this, then B will move like this. If A moves like this, then B will go like this. So you see here, A and B, their motion are interlinked. Their motion are interlinked. Okay, so let's try to do the same thing here, step by step. First step, what was the first thing? Specify the fixed datum. Okay, now if you see here, there is this pulley. We can put this pulley as our datum because this pulley is fixed. It's not movable. However, we cannot put this pulley as our datum because this pulley can move up and down. So this pulley is not fixed. So we cannot put it as datum. This pulley, it is fixed. So we can put it as our reference as well. So this is our reference. This is our reference, but that is not our reference. So that is the first point. Specify the fixed reference. Second point, draw the datum line. So motion of B will be up or down. So my datum line should be like this. Motion of A could be horizontal, right or left. So my datum should be vertical. So point number 2 done. Datum, I have drawn the datum for both the case. Now remember, if B is moving towards the datum, that's negative. If B is moving away from the datum, positive. If A is moving towards the datum, negative. If A is moving away from the datum, positive. So that was my point 3. We should specify what's positive and negative. Okay, is it clear so far? Is it clear so far? Okay, good. Okay, so point number 3 is done. What was the fourth point? I don't remember the fourth point. Let's see. The fourth point was 2, 3, fourth. Identify the number of ropes. Now, how many ropes are there? So if I see the number of ropes, so there is one big rope here. Okay. However, there are some small ones as well. One connected with B, one connecting this pulley to the fixed reference. Okay, this is not a rope. This is a member, but anyways, you see here, but these ropes have no variable. Why? Because they are not in motion. This one B is in motion, but it's still this distance, the rope length is not going to change, and there is no variable here. It remains constant. Okay, so it constantly moves with this pulley. So we can ignore these ropes, the small ones. Okay, why? Because there are no variables here. So actually we have one big rope with variable. We have one big rope with variable. Okay, so now we have identified that there is one rope. Now what we need to do is we need to write the equation for the rope. Now you see one thing, when we have to write the equation, even the last time when we wrote the equation, wherever we had a constant, the constant was automatically deleted, because when you differentiate it with respect to time, the constant goes 0. So right now we can just ignore the constant straight away. Okay, so let's start from one end. Let's say we start from this end. So here, before the datum, this is a constant, so let's ignore the constant. So we have SB here. Then after SB, you have another constant here, which is passing through this pulley. Then you have again SB plus SB. After that, you have another constant, which is passing through this pulley. Ignore it. Then you have this height H. But if you see here, the height H is also constant, because this height H is between this pulley, and both pulleys are fixed. So this length is not going to change. So let's also ignore it. Let's also ignore it. Then you have a constant here passing through this pulley, ignore it. And then you have this length, let's call this SA, so plus SA. Okay. Okay, so this is the length, IT, you can say, differentiated with respect to time. So what we will get? We will get 2 VB plus VA equals to 0. So I made the equation for line, for the rope, ignored the constants. I ignored the constants and then differentiated to get this equation. This step, is it clear or not? Please feel free to ask if it is not clear.
The first equation is equal to 0, right?
I put it here any length, okay? LT, let's say you call it LT, because it's not 0. SB plus SB plus SA, these are some length. It's not the total length, but these are some length. So let's call that LT. Okay. But this equation is not important. In reality, your relationship will be this equation. Velocity, and if you again differentiate, then a relationship between accelerations. So your point of interest will be the relationship between the motion of B and the motion of A. So if you know the motion of B, you should be able to find out the motion of A. If you know the motion of A, you should be able to find out the motion of B. So the first equation is just, you can say, a helping equation to develop the second equation. And second equation is the main equation, which is relating the velocities, or if you differentiate again, it will relate the accelerations. Okay, is it clear? Anything anybody want to ask again? Okay, so let me rub it. So you can see here, certain 2SB, they initially put H, but eventually when you differentiate it, then H is also a constant. It will go to zero, like IT goes to zero. So it's 2VB equals to negative VA, or 2AB equals to negative AA. Okay. So let's have an example. Okay. Remember, you need to follow all those 6 points. If you follow the 6 points the right way, then no problem. Okay. So look at the example here. In the figure on the left, the chord A is pulled down with a speed of 2 meters per second. Okay. So let's have a look here. This is our chord A, and it is pulled down with 2 meters per second speed. Okay, so just look at it. What will happen when you pull this down? When you pull this down, automatically C will go up. When C will go up, automatically this pulley will go up, and so the B will go up. So when you are pulling this down, this B load is going to go up. Okay, so this is the effect. So now we need to know what will be the speed of block B. We know the speed of A, it is going down with 2 meters per second, but we don't know what is the speed of B. So we need to find this out. What will be the speed of A? So we can find out if we make a relationship between A and this pulley, let's say this point. If we make a relationship between them, if we know what is their relationship, since this is block B, let's call this B. Okay. So before going towards the solution, first of all, do you understand the problem statement? Yes or no? Good. Now let's go towards the solution. Again, for the solution, I have to follow all the 6 points. Point number 1, specify the fixed reference. Okay, this pulley cannot be the reference. It's movable. This pulley cannot be the reference. It's movable. But this is fixed. So let this be the reference. Point number 1 done. Let's go to point number 2. Draw the datum line. So datum line can be from the fixed reference. And since the motion of A and B is up or down, and similarly for B could be up and down, so the datum can be drawn perpendicular to it. So that will be the datum line. So point number 2 is done. Okay. Now, point number 3, specify the positive and negative motion. Okay. So If you see here, there is point A, and there is one variable here. Let's call this SA. Okay, SA. Okay. Now this is one variable SA, but then you will have another variable here. Let's call this SC. Okay, let's call this SC. Remember, SC is different than SA because SA will increase when SC will decrease. When the SA will increase, SC will decrease. So just by the nature of the problem, you will understand that SC is different than SA. Okay, and then you can have one SB here from the datum to this pulley. Okay, drawing everything here by mouse is difficult, so let's move towards the actual picture so that you can see it. So let me, so I think now it's visible well. So you see here, this is SA, this is SC. Somebody might say, Dr. SA and SC look same. Can we just call both of them SA? No, they are different in nature. SA will increase when SC will decrease. They are not going to move the same way. So this is the thing. You remember in the very first lecture I told you dynamics is difficult because the things are in motion and you are solving things in motion, but you cannot see the motion. You have to imagine it. If your imagination is not good, you won't be able to visualize the motion. If you cannot visualize the motion, you won't be able to understand the problem. And this is the biggest problem with this course because students find it hard to visualize the problem. So SA is not the same as SC. It looks like in the diagram here as same, but if you visualize the motion, when SA will increase, SC will decrease. So there are two separate motions.
But doctor, VA and VC, it will be same, right?
Sorry?
VA and VC
We cannot say.
are same.
We cannot say.
Uh,
We cannot say this, okay? We will develop the equation and then we will find out. Okay? So when we say VA means the motion of the hand. When we see VC, that means the motion of this pulley, C. Okay? And when we say SB, SB is the motion of this pulley. Obviously, with this pulley, this block B will move as well. Okay, so anything moving towards the datum, negative. Anything moving away from the datum is positive. Now tell me that when it is said that A is moving down, A is pulled down, do you think that, so it's written VA is 2 meter per second. Do you think this 2 meter per second is positive or negative? Uh, Getting answers from you are difficult in the Zoom, but anyways, it's yes, it is positive. Why? Because it is moving away from datum. If it was moving, if it was said in the question that A goes up, then it was moving towards the datum, then it would be negative. So here, keep that in mind. VA is positive because it is moving away from the datum. Okay. Najwa said negative. Why? I don't know. Okay. So let's discuss. Okay, so point number 3 is done. Let's move over to, yeah, if it was moving upward, yes, then it is negative, yes. Okay, point number 3 is done. Let's move over to point number 4. Now we need to develop the equation, okay? What was point number 4? I forgot. Identify the number of ropes with variable motion. Yes, number of ropes. How many number of ropes here? Now, if you see here, there are 2 ropes. One is this, and the other one is this. There are 2 ropes with variable motion. Okay, so how many equations there will be? 2 equations. One equation for one rope, another equation for another rope. Okay, So let me start writing equation for one of the rope. Let's say we start from this end, this end. So it will be SA plus SC and then again plus SC. So it will be plus 2SC, or let me write directly in the velocity format. VA plus 2VC is equals to 0. Is it clear or not? I wrote one equation for one rope. Is this equation clear or not? Okay, good. Now I need to make another equation. Okay, so another equation would be what? This rope. Okay, so let's start from this end. Okay, so it should be SB plus this. Now how do I find this? This we can write it as SB minus SC. If this total is SB and this one is SC, ignoring the constants, then this part of the rope, which is a variable, that would be SB minus SC. So this plus SB minus SC equals to, okay, if I write in the terms of the velocities, so VB plus VB minus VC is equals to 0. Now this equation, do you understand it or not? Just we are making the equation for the rope, ignoring the constants. Remember, this rope, this is constant. This rope, this is constant. And this portion is constant. Okay, so ignoring the constants, so total length will be SB plus this length. But this length, how do we define this length? It would be SB minus SC. So it will be VB plus VB minus VC. So it will be 2VB minus
Doctor,
VC equals to, yes.
it's not clear why it's the rob it's VP minus VC. Why
VB
is it
minus
like that?
VC, why it's not clear? Look, when this pulley will move up and down, when this pulley B, when this is going to move up and down, so this length is going to change. Okay, this length is going to change. It's going to increase or decrease. Do you agree this thing or
Okay.
not?
Yes, yes.
How do we specify this length? Okay,
When
this length we
VC
can
is more.
specify as the total length from the datum we had from this pulley minus this SC.
Okay.
We remove the constants, so just ignore the constants. The constants are these wherever it's passing over the pulley or going into the pulley or above the datum. These are the constants. Okay, just ignore the constants, think that they are not there. Okay,
Okay.
so now if you want to just find out how much is this length, so it will be total SB minus SC. Got it? So this becomes 2VB minus VC equals to 0. Do you understand this equation? This is the equation for second rope. This was the equation for the first rope. Okay, is it clear or not? Okay, now look here. We need to find what will be the velocity of B when we know the velocity of A. We have a relationship of A and C. We have a relationship of B and C. Can we find the relationship between A and B? We can. If we have a relationship between A and C and we have a relationship between B and C, we can find a relationship between A and B. This is simple mathematics. Okay. So we will develop a relationship between this and So we will have one equation relating A and B. Once we have that relation, then we can solve the problem. So let's come to it. Okay. So you see chord 1, SA plus 2SC equals to length 1, SB plus SB minus SC length 2. This is chord 2. Then we just eliminate SC. So we get a relationship between A and B. So relationship between A and B is what? VA plus 4VB equals to 0. So VA equals plus 4VB equals to 0. Now we know VA. VA is what? VA is 2 meter per second. So just substitute 2 meter per second and you will get VB is negative 0.5 meter per second. When it says that VB is negative 0.5 meter per second, that means VB is moving towards the datum at a velocity of 0.5 meter per second. The problem is solved. Do you understand the solution or not? Is the solution clear? Okay, good. Okay, now we have another problem, but before moving to that problem, do you want a break of 5 minutes? Actually, I want a break of 5 minutes because speaking make me tired a little. So let's have a break of 5 minutes and then we will start back. Okay, Assalamu alaikum. Let's return back. So we did an example before. Let's have another example for pulley system. In this pulley system, students, you are able to hear me? Yes, okay. In this pulley system, block A is moving downward with a speed of 4 feet per second. So A is moving downward. Speed is given. While block C is moving up at 2 feet per second. Okay. We need to find the speed of block B. Okay. So our procedure of solution will be same. First of all, we will need to find fixed reference. So this cannot be the fixed reference. So we can have this one and this one as a fixed reference. Okay, then we can draw a datum line at the reference. Okay, then specify the variables. So let me just show this. Okay, so datum line is drawn, then specify the variables. This will be SA, this will be SB, and this will be SC. Positives and negatives are identified whenever something is moving towards the datum negative, away from the datum positive. Okay, then the next thing is that how many ropes we have? We have one main rope. Okay, so that's point number 4. Point number 5 is that we need to write the equation. So equation will be what? SA plus SB plus again SB, then plus SC. So it will be SA plus 2SB plus SC equals to 1, or you can say VA plus 2VB plus VC equals to 0. So we get this equation. Before moving forward, is there any student who do not understand how do we came up with this equation? Okay, that means everybody understood. Let's move ahead. Now we need to find the velocity VB. We need to find this velocity VB, and we already have velocity VA and VC. A was moving down, C is moving up. So what do you think? Will the velocity of A be positive or negative? So it will be positive. And what about velocity of C? Will it be positive or negative? It will be negative. See? So velocity C is negative, velocity A is positive. Okay? So once you have this, you substitute it into the equation, you get the velocity VB as -1. Velocity VB is -1. What do you think? The block B is moving towards the datum or it's moving away from the datum? -1 answer, towards, exactly. Because it is -1, that means block B is moving up. So that's it. If you just follow those steps as I mentioned you in the right sequence, in the right way, then inshallah the solution for these kind of problems is not difficult. So chapter number 12 is now officially finished. So now we are going to start towards chapter number 13. So chapter number 13 is Newton's law of motion. Newton's law of motion, uh, basically it is the Newton's second law of motion, which is F is equals to ma. This is the second law, and we're going to work over this law a lot. There is Newton's law of gravitational attraction as well. You can go through it yourself. Probably you went through this equation in physics or chemistry before as well. Mass and weight. Uh, Weight is mass multiplied by gravity. Weight is a force. It is the force with which an object is attracted towards the earth. So, anyways, unit of weight is Newton, unit of mass is kg. Equations of motion, summation F is equals to ma. We have been using this equation before in statics as well. But since it was statics before, so in statics you do not had any acceleration. Since you had no acceleration, it was zero, so summation F was zero. So you used to work over this equation such that you used to develop the equilibrium of forces. And equilibrium of forces was summation F is equals to zero. This time summation F will not be equal to zero, rather it will be equals to ma. Okay. Okay, so previously, even in statics, you used to do that you used to develop the free body diagram. Free body diagram is a very fundamental and key diagram, and it is something that if you draw it correct, you would be able to proceed with the problem in the correct direction. But if you draw the free body diagram wrong, then your initial point, your problem initiation itself is wrong, and then you won't be able to proceed the problem in the right way. So free body diagram itself has a huge significance in that sense. So you're not going to get rid of free body diagram. You're going to continue drawing the free body diagram here as well. But along with the free body diagram here, another diagram is needed, and that is the kinetic diagram. So let's say this one, for example, we have a body here which is connected with a rope and a pulley arrangement, and this body B is connected with the pulley. Okay, so this A is a block, B is a cylinder, and whenever there is a motion. So let's draw the free body diagram for this case. So if you look at the block, so it is connected with the rope, so there will be tensile force here. Okay, the block itself has a weight, which will be acting down. Okay, and since the block is resting on the surface, so there will be the normal force of the surface. And since since the block is moving in this direction, so there will be the force of friction, which will be there in the opposite direction, and force of friction will be mu multiplied by normal force. So this will be the free body diagram for the block. Okay, and if we draw the kinetic diagram for the block, so the block, there's a mistake here. The block is moving in this direction, so the arrow should be like this. Okay, so it's like this. So this is the block A. That's a kinetic diagram. Kinetic diagram is F is equals to ma. So ma is the kinetic part. So we just draw the direction and we write ma, and that's the kinetic diagram. It's kind of a useless diagram, but you have to draw it. So this is kinetic diagram for block A. This is free body diagram for block A. Okay, block B. It was connected with a pulley. So there are two ropes, and each rope has a tension. So 2T is going up, and the weight of the block B is going down, and there is nothing else. So that's a free body diagram for block B. Very important diagram. The block B might be moving up or down. Okay, let's say it is moving down. So we draw an arrow in the downward direction and write MAB, because summation F is equals to MA. So it will be MAB. So that will be the kinetic diagram for block B. Kind of a useless diagram, but you have to draw it. So 4 diagrams here. 2 diagrams for block A, 1 free body, 1 kinetic. 2 diagrams for block B, 1 free body, 1 kinetic. And for all 4 diagrams you have to draw for the solution. So anyways, this problem, we are not solving the problem. We just had to draw the free body diagram and the kinetic diagram. Anybody has any question in the drawing of the free body and the kinetic diagram? Okay, so let's move ahead. Let's see this problem. Again, we are not solving the problem. We're just going to draw the free body and the kinetic diagrams. Okay, so there is a force applied to this block in this direction, and so it will cause the block to move so there is force applied over the block in this direction, so it will cause the block to move in this direction. And when the block will move in this direction, it will compress the spring, and the spring will apply spring force in the opposite direction. Okay, so we have this, and it is said in the problem that the contact surface is smooth. Since the contact surface is smooth, so there won't be any resistance, so there won't be any friction. So let's see the free body diagram for it. So you see here, force is acting in this direction. There is weight of the block, which will be acting down, and there will be a normal force acting up, and there is the force of spring, which will be acting in the opposite direction. And then obviously there will be F summation F is equals to ma. This is the kinetic diagram. Mass is 10, so it's 10a, and in this direction. So that's the kinetic diagram. That's the free body diagram. So anything anybody who did not understand, you can ask. Okay, so equations of motion, rectangular coordinate section, blah, blah, blah. Rectangular coordinates. We used to solve the problem in summation fx, summation fy, summation fz. Previously, they were used to be zero because it was a statics. Now it is dynamics, so they might not be zero. So now summation fx equals to max, summation fy equals to may, summation fz equals to maz. There is a relationship between static friction and dynamic friction. Static friction is whenever it's there, so there is no motion. Force is applied, and with the application of the force, the static friction also keeps on increasing until a time is reached when the object start moving, and then it is the dynamic friction, and the dynamic friction is constant. So anyways, these are the concepts you already covered in statics most probably. So it's just a revision. Okay, let's have this problem. The 50 kg crate shown in the figure rests on horizontal surface for which the coefficient of kinetic friction is mu k zero point 0.3. If the crate is subjected to 400 Newton towing force as shown, determine the velocity of the crate in 3 seconds starting from rest. So this is a problem. We have the crate here. Is a force applied of 400 Newton. Initially the crate was at rest. That's initially starting from rest. We need to find what is the, determine the velocity of the crate. What's the final velocity? In 3 seconds. So this is a case where we can say that acceleration is constant. So for constant acceleration, we can use equation number 7, most probably. So it was V equals to V naught plus ACT. Okay, so time is given 3 seconds. Initial velocity was 0 starting from rest. Final velocity you need to find out. If you have the acceleration, you can find out what is the final velocity. Okay, so how to find the acceleration? For finding the acceleration, we have to apply, we have to do the force balance. So the crate is on the ground. So we can first we need to draw the free body diagram. The free body diagram would be like this. Let me, the free body diagram would be like this. So we have the crate. The weight of the crate is known, so we know what is the force of weight. Then we know that 400 Newton is applied at 30 degree. There will be normal force which will be acting upward. And since the crate is moving in this direction, so there will be the force of friction in the opposite direction. Okay, so now we can have summation of forces in x direction and summation of forces in y direction. One thing is clear, that the crate is going to move horizontally. Since the crate is going to move in horizontally, so summation fx will be equal to max, but summation fy can be put equals to 0 because there is no motion in the y direction. So the acceleration in the y direction is 0. So we can write here is, if we have summation fy, so we have the normal force, we have the force of the weight and the component of 400 Newton in the y direction. So it's NC minus 490.5 plus 400 sine 30. This is equals to 0. We can find what is NC. Then we can have the equation for summation fx. So it will be 400 cos 30 minus 0.3 NC, which is the friction force. This is equals to max. This will not be 0. So it will be 50a. And this acceleration will actually be the one that once you determine this acceleration, so this will be placed here and you will get what is the final velocity. So we get NC, we get A, we substitute it here, and we get what is the final velocity. So that's the solution to the problem. Is there anything which is not clear within the solution? Please ask. Okay. So you see here, there is a free body diagram drawn here, and also there is a kinetic diagram drawn here. So both diagrams are important. When you come into the exam and you have to draw, you have to solve the problem. For solving the problem, you have to draw both free body diagram and kinetic diagram. It will not be written in the question that draw the free body diagram and the kinetic diagram, but it will carry marks. So you have to draw both diagrams. Now, one question students most of the time ask the doctor, it's very clear that free body diagram is important diagram. Why do we need to draw the kinetic diagram? It's look like a useless diagram. I know it looks like a useless diagram, but you have to draw it because it will carry mark. Okay, so okay, let's move ahead. Okay, let's see this problem. The 100 kg block A shown in the figure is released from rest. So this block A is 100 kg and it is released from rest. If the masses of the pulleys and the cords are neglected, determine the speed of 20 kg block B in 2 seconds. So this is released from rest, and now after 2 seconds we need to find what will be the velocity of block B. So how can we solve this problem? We know that this velocity, this block A is released from rest. Okay, so we can find what is the velocity of block A after 2 seconds, but then we do not need to find the velocity of block A after 2 seconds. What we need is we need the velocity of block B after 2 seconds. So we can have a relationship between block A and block B, and that relationship is going to tell us that what will be the velocity of block B after 2 seconds. So let's have a solution for this problem. So we need to consider each block separately. So when we consider block A, so it will be this pulley that we need to consider, C. Okay, so okay, let's first develop the relationship between A and C. Okay, so let's first develop the relationship between C and B. I'm sorry. Okay, so we have to specify the fixed reference. Then this is the datum. So now if there is one main rope, so if we develop the equation of the rope, it will be SA plus SA plus SB. So 2SA plus SB equals to the length, or we can say that 2VA plus VB equals to 0. Okay, so now I'm doing it directly. Or we can say that 2AA equals to negative AB. So this is the direct approach. We did it, but we went through all the steps just today. Okay, so 2AA equals to negative AB. Now, since we put our datum up, so anything moving towards the datum is negative, anything moving away from the datum is positive. So let's put y positive in the negative direction so that it coincides with our datum selection. Okay, so if we put y positive in the negative direction, then so summation Fy equals to may. So it will be the weight acting in the negative, weight acting down, it will be positive. Negative 2t equals to may. Okay, so it will be MAA. Then we can have the equation for the other block. It will be the weight of block B acting downward plus 1t, minus t is equals to 2AB. So here we have two equations with three unknowns. Acceleration of A is unknown, acceleration of B is unknown, and the tension in the rod is unknown. Then you can have another equation between AA and AB. So we have three equations and three unknowns. So we can actually find what are the three variables, T, AA, and AB. So once you have the acceleration AB, then we can use that as V equals to V naught plus ABT. Initially it starts from rest, so it will be 0. And then we can write AB, which we already found. And then after 2 seconds, we can find what is the velocity. Negative sign indicates that it is moving towards the datum. So anything which is not clear in the solution of this problem, you can ask. Is the solution of the problem clear? Okay. If it is not clear, please feel free to ask the point which is not clear. Okay, so the solution is done. Let's move to another one. This will be the last problem today, and then we're going to finish today. Anyways, next week, inshallah, we are going to finish chapter number 13. Okay, a 10 kg projectile is fired vertically upward from the ground with an initial velocity of 50 meters per second. Determine the maximum height to which it will travel. Number one, if the atmospheric resistance is neglected, and number two, when the atmospheric resistance is measured as Fd equals to 0.01 v square, where v is the speed of the projectile at any instant. So when the projectile is fired, when this projectile is fired, let's see that what are the forces acting on this projectile. Okay, so when there is no resistance of the atmosphere, so it's just the weight of the projectile which is acting downward. Okay, so summation F is equals to ma. You can write here summation F is equals to ma, and summation F is basically what is the weight, 98.1, because it is 10 kg and it is moving downward. So it's negative 98.1 equals to ma. So your acceleration will be negative 9.81 meter per second square. Okay, so you have this acceleration, negative 9.81 meter per second square. So now we need to find how much is the height that it can follow. Since the acceleration is constant, so we can use the equations for constant acceleration. There are three equations for constant acceleration. You have the right to choose any equation you want. Here in the book, they have used this one. This was, I think it was equation number 8. This was equation number 9, I think, 7, 8, 9. This was the ninth equation. So V square equals to V naught square plus 2AC Z minus Z naught. So when the projectile will be at the maximum height, the final velocity will be 0. Initial velocity is given. What is the initial velocity of the projectile? And acceleration we just calculated by equilibrium of forces. And the height will be h, so you can find what is h. Before moving towards the next part of this problem, I need to know that do you understand part A or not? Is part A clear or not? Okay, if part A is clear, let's move towards part B. But the part B is not that easy, so let's deal with it. So part B, what was asked in part B? In part B is that when the atmospheric resistance is not neglected, rather atmospheric resistance is measured as Fd equals to 0.01 V square. So previously we had just the weight acting downward. Now you have the weight acting downward plus the atmospheric resistance is also acting downward. So now you have this situation, weight acting downward and atmospheric resistance acting downward. So there are two forces acting downward. Okay, so weight acting downward is this. So this part of the equation is the same as before, but now you have an additional thing, which is this. Because the resistance, because the atmospheric resistance is given as 0.01 v square. So we have to write here 0.01 v square, but it's acting downward. That's why with a negative sign. So we have negative 0.01 v square, negative 98.1 equals to 10a. Now this is the equation. So that means our a becomes equals to negative 0.001 v square plus 9.81. Now acceleration is not constant. This time you cannot use this equation. Equation 7, 8, 9, 10, all these equations were for constant acceleration. This time acceleration is not constant. Acceleration is a function of velocity. So you cannot use the constant equations. So you have to move back to the first six equations, where the first three were in the differential format, and equation 4, 5, 6 was in the integral format. Okay, so we can use this one, a ds is equals to v dv, because a is a function of v given. So we can write a as a function of v, and we need to find the distance. So put v on, put distance dz on one side and all other things on the other side, and integrate it. When you integrate it, so when the distance is 0, the velocity is 50 initially, and the final velocity will be 0. So we need to find what is h. Okay, so I mean, these are the limits of integration. So now you integrate this thing. Now how this thing become this, it is not a question of dynamics, it is a question of mathematics. And I hope you guys are perfect in mathematics. So you will come up with it, that how this thing becomes this thing. Now it's no more it's not no more a problem of dynamics. Now it has become a problem of mathematics. Okay, so the integral of this thing becomes this thing, and you apply the limits. Okay, and after that you get h is equals to 114 meter. It makes sense. When you have atmospheric resistance, the h will be less than when you don't have atmospheric resistance. So other than this integral, if you do not understand that, other than this integral, is there any part of the problem that you do not understand? Because this is a problem of mathematics, that's why I'm saying other than this. Other than this integral, if you do not understand this thing, that's another thing. But other than this, is there any part of the numerical that you do not understand? Feel free to ask. Remember, we could not use the previous equation because these equations are for constant acceleration. But this time our acceleration is not constant, it is a function of velocity. So we cannot use equation 7, 8, 9. We have to move back to the first six equations. Since we need distance and we have acceleration as a function of velocity, our best choice is this one, ADZ or ADS is equals to VdV. So anybody wants to ask anything, please feel free to ask. Other than that integration, that you have to see it yourself, or you can ask help from any mathematics faculty. But anyways, it's a simple integration. There's nothing difficult about it. Nobody has any question. Okay. So far everything is clear. Of course, mathematical steps are graded in the exam. Sure, sure. They have grades, but they don't have a lot of grades. Maybe 1 mark, 2 mark out of 10. So out of 10, 2 marks, not a big amount, right? Okay, so we stop here at this point. Inshallah, next week we are going to start from this spring force and then other parts. So, anyways, next week, inshallah, this chapter 13 will be finished. So today we are done till this point, and let's just stop here. Anybody want to ask anything? You can ask. Otherwise, we are done today. Okay, nobody has to ask anything. So if you want, you can leave the meeting. The lecture is over.